Welcome to this series on YOLOv5, an advanced AI algorithm commonly used to detect objects in an image. It can also perform image classification and segment objects within an image. Before we dive in, I want to take a moment to give credit where it's due. My hat goes off to Glenn Jocher, founder and CEO at Ultralytics, for the development of YOLOv5. His outstanding work has made a significant impact in the field of computer vision and AI. And this series will not be possible without the code he developed, as well as to the many GitHub contributors. YOLOv5 was first released in 2020, and there has been a number of releases since then, with the latest one released in 2022 for the YOLOv5 Release 7, which is the one that we will be using. Additionally, newer versions have been also developed since, such as YOLOv8, also developed by Ultralytics and released in 2023, and the latest additions to the YOLO family, YOLOv9, as well as YOLOv10. Both released in the first half of 2024, in this case by academic institutions. However, while there may be a temptation to focus and study these newer versions instead, I think it's important to mention that these latest versions are built on the Ultralytics Python package, as is the case for YOLOv10, as well as for YOLOv9, where again it builds upon the robust code base provided by Ultralytics YOLOv5, showcasing the collaborative spirit of the AI research community. So to this day, YOLOv5 continues to be, if not the world's most, according to Ultralytics, certainly one of the most loved vision AI algorithms and used across a wide number of industries and applications, which is why we will focus on this version, YOLOv5, during this series. Quick disclaimer here, I've been working on this series during my own personal time, and I have no ties to Ultralytics, just grateful for their open source code. Making these videos came out of my own satisfaction of learning the YOLOv5 inner workings and the extra effort that goes into understanding something well before publishing it to the broader community, with the best intentions and for educational purposes, and I've spent time to understand and try to explain the concepts in the best way possible. However, I apologize in advance if there is an occasional error or if a concept is not clearly or sufficiently explained. This is not meant to be your only resource for understanding YOLOv5, but rather one of many in your AI journey. So with that, let's focus on the YOLOv5 GitHub repo. So to start with the basics, you could run YOLOv5 in just a few minutes by opening the Colab and then just running these two cells right here, this one, cloning the code, and this one, in this case, to detect two images that are in data images. Data images. However, what we're going to do instead is download the code by running these three lines here. So we could run the three at a time or just one at a time. Let me do the first one first. So open your terminal. And in this case, make sure that you are in the folder where you want to clone YOLOv5. In this case, this is the folder where I want all this code downloaded, all these files. So I can just paste these and run it, and we'll be cloning the GitHub repo of YOLOv5. Now the code has been downloaded, and we can actually see it here, where now we've created inside YOLO the YOLOv5 folder. And now what we're going to do is step into that folder. And now we have all of our files here. And now the last thing that we're going to do is install the libraries. So we'll just copy this. What we are doing is here, all of the libraries are going to be installed. We'll just paste that, and then we'll run it. You can either install it in your Conda environment if you have one, or directly as I did, just with that command. Okay, so all the libraries have been installed. And then we can go here and delete these two images, and then download and paste the image that you see in the comments instead of these ones right here. So what we'll do is we delete these two, and we'll paste the Explorer image. And then here, we just paste this, Python detect.py, and then YOLOv5L in this case. I'll explain later why in the next video. And then data images, the Explorer image that we just saved right here. And with that, we run it. And then we obtain this. So feeding in this input image, we obtain this output image of the bounding box of the object of interest with the label as well as the confidence score. So this series will be mainly focused on going from this input to this output. So something that we did very quick is going to take us through this series where we're going to go step by step through the code in order to understand what is happening from input to output. So I'll see you guys in the series. Now, before we do that, let's go ahead and delete this folder here, as well as these 1 or 2 models that you have here, as we are going to download them as we step through the code step by step. So I'll see you guys in the next video.